Hello, hello. How are you today? Are you good? Yeah. Okay, are you ready for a talk about Git? Who here uses Git? Okay, well, we all agree on that. So today I want to talk about Git, but it's not like the usual talk when we are going through like commands that we can do with Git. We are going to go a little bit in deep on what it actually happened when we run those commands. So a little bit about me. I'm a senior software engineer at a small company in the north of Italy called Atlantis, and I do mainly front-end stuff, and I really like to play with electronics, so if you like electronics, come talk to me. And I like to speak at conferences about like front-end stuff and also like other, let's say, coding utilities. So software versioning, I wanted to do a talk about versioning our code because it's not something that it's really up to everyone. Because like I worked with junior developers and also like senior developers, and sometimes we struggled with people to versioning our code. So I wanted like to do something to talk about this thing. So in particular with Git, because like we've seen that everyone uses Git mainly. So what it actually means to version our code and to use Git. So Git is a version control system that allows us to work with other people. So we are like working on a project, but not every time on our own, but we need to be able to work with other people. And that's like really help us to work on the same project with other people. So it was created in 2005 by Linus Torvalds, and it wasn't like his actual aim to build something like that, but he really, it was like really helpful when he developed the Linux kernels. That happened, and we are really happy with that. There is a difference between the centralized version control systems and the distributed control system. That's what it's Git about. The difference is that with Git, for example, we have the whole history of our code, so the whole repository with all the history in our machine. So we don't like just work with the changes, but we work with the entire history. And that's really helpful because like we have a copy of all the projects in our machine, and we can actually work with it without like many issues when we work with other people. And it's actually widely used. There are like really millions of developers worldwide that use Git, because I think it's the most popular one, and everything, we all use that. So what I want to talk about today is understanding what are like the main components inside our Git folder. And the main components of Git are the objects, and we want like to go through them and see what are them and how we can work with them. So Git is actually like a file system. So we have like a bunch of directory, and all the data is stored inside this directory. So let's try to understand what the directory are about. So every directory, it's mainly represents a Git object. And the three main types of object that we have in Git are the commit object, the tree object, and the blob object. So we start from the commit object. Inside the commit object, we have always a reference to the tree that is connected to. So then we have like the tree object, and in the tree object, we have the reference to other tree objects or the blob object. So this is like the three main objects that we are going through today and that are fundamental for Git understanding. Every object is actually identified by a unique SHA-1 hash that has like these 40 characters that allows us to have different a different ID to every object that we are using. And this is like ensure us that even the smallest change in our project will be like saved in a different object with a different hash. So let's see like in action how it actually works. So here I will like create a new Git project. So I'll do a git init Codegarden repo. So I've created my new repository. Oh, this is not. Okay. So I will create like a new repository, and I will go inside this Codegarden here. So once I'm inside, I want to create, for example, a new file where I will just write something like hello Codegarden, like this, and I will save it inside a hello.txt file. Okay, so I need to add this new file because I have a new file that is hello here, and I will do a commit, git commit, add a message that is like our first commit, usual commit message, let's say. So once we are in here, I want to see what actually happened inside my .git folder. So I just want to see what's inside. So here we have like all this directory. What we are going to go through today is the objects folder. So I will go inside the objects here, and you can see that we have 4 folders. The 3 first of them, you have like these 10, 4F, and A9 that are like 3 folders that has the name as the beginning of the hash of the 3 objects that we were talking about. So the first one is the commit object, the second is the tree object, and the third is the blob object. So once we'll go through them, we'll see that the hashes of the objects will like really begin with those particular characters. So let's move to our object. The first object is the commit object, and I think it's the most important one because we have like, it will represent what we actually did in that particular time of our project. So it's like a snapshot of the project of a specific point of time. And it actually contains the commit message and also like the pointers to the tree object and the references also like to other commits if we have like parents commits before that. So usually when we think about a commit, we think about the changes that we did inside our project, because like of how we see it maybe on GitHub, we can see like the red lines and the green lines. So we think that just the changes have been like saved in that particular moment. But it's actually not just the changing, but we are saving the entire project every time that we do a commit. So that's really important. The anatomy of a commit object is that we have inside the commit message, so the message that we actually written once we did the commit, the tree pointer, so the hash of the tree that is connected to, and also like if we have like parent commits, we have like references to previous commit that we did. So let's go back to our demo. Here, if we want like to go inside our git commit object, we are gonna see, let's do a log, one line. to see what we have just one commit that was like our first commit. So we want to go through that, and we have it in head. As you can see, like the beginning of the hash is that 103C. So we want to get it. And to get it, I will do a git rev parse of head. Here we have the hash of that commit, and we pointed to head because it's the last commit that we did. I want to save this inside a variable that will be SHA, for example, and I will save this that we just did. I'll just copy this. We have seen that it works, so we'll have it inside what I did wrong. I don't need this at the beginning. OK, so I just saved the hash inside this variable, and now I will go through what type of object is this hash referring to, and also what's actually inside. So we want to go inside and see the content of this object. So to do this, I will do a git cat file, and this means that I want the type of this object, and is our SHA here. And we've seen that the type is a type commit, and I will do a p to have the content of it. And here you can see like all the information that we have. So we have first commit, that is the message here. And we have the information about the commit, so the committer, the author. And here the most important one is the tree. So we have the reference of the tree that is connected to. So the tree object, and here you can see the tree hash. So let's go through what a tree object is. So a tree object is actually an object that represents, let's say, the hierarchy of our project. So it actually represents all the directories that represent the project and his structure of the project. So the tree are actually really important because it will, they will like references how our project is actually structured. And for every commit, we have like a tree where the commit is referring to, and every tree is connected maybe to another tree, so another directory, or like it has inside the actual blob where the blob is positioned, and the blob is actually the file that we have been working on. So the anatomy of a tree object, what we can look inside, we have the blobs, so all the files that we've worked that are inside that particular directory, or other directories, so other trees objects. So inside we'll see mainly blobs or trees. In this case, for our demo, we'll find just one blob. Let's see. So here we want to do a new variable that is our tree that will contain our git cat file. I want to recreate this part. So I want to take the information about the commit object, so I can like go through the first line and get the second column that is the actual hash of the tree. So I'm gonna do git cat file -p SHA. So this is what we've done earlier, but I want some more specific parts. We want to grep tree. So I want the line that starts with tree. And also, I want to get the second column. So it's awk. Let's get it correct here. It's print the second column. It should be right here. No. I need to do it again. I will do like this. So let me see what I did wrong here. Oh, I missed. No. This. No. So here I have this. Let's try this one.
Don't you need to like recreate the star error now that you've made a new terminal?
Yes. Yes, because I've deleted everything. Okay. Thank you. So let's do the SHA again. That will be our git rev parse of head. Okay, let's try this again. Okay, I will just print this. As you can see, it's correct. So we have the hash now, and now we want to go through that and see if it's like really a tree object and what's inside it. So let's do a git cat file. It's always like the same, but in this case, we want the type of the tree. Here we have the tree object, and if we go inside the content of it, we'll see that we have just one blob, that is the file that we've created, that is the hello.txt, and here we can see that is this, the type blob, and here we have the hash of the blob. So in the next demo, we'll take the third column of this line to get the blob object. But what's the blob object is? It's actually the simplest object in Git because it actually don't contain any reference to the commit or the trees, but it actually contains just the content of that particular file. And the most important thing, because when we think of doing a commit it actually saves all the, not just the changes, but everything in our project, even the files that we didn't like change. What's actually how the blob works? If we have like many files that has the same content, it will not save another blob, but it will use the same blob. So actually Git will save space with that because it will be stored just one time, and it will like just get the same reference to the blob without like creating new blobs every time. So if we see the anatomy of a blob object, inside we don't have like any reference, we just have like the raw data of that file with no references to commits or trees. So this is like really useful because it will save us a lot of space inside our projects. Here we have the demo about the blob. So what I want to do is the same thing. I want to create the blob variable. Let's get it right this time. So I'm gonna do this git cat file of the tree here, and I want to take grep blob in this case, because I want the line that contains the name blob, and I want to get the third column because we have the hash in that position. So it's awk, and I want this. so I don't get it wrong. But not the second column, but the third one. So let's see if it's correct, but I think it is. Here you can see that we have this hash that is exactly this one that we get from the tree. So once we have this, we'll do the same thing again. So we're gonna see if it's actually a blob type, and it is, it's a blob, and we want to see the content of it. And it's actually, we have just the hello Codegarden. So it's just the content. It's not refers to the name of the file. We don't care about it. We just want the raw data to that. Because if we have like another file that is like hello.2 that has the same content, it will like just store in one place. So for example, in this case, if I want like to create another file inside my project, for example, I want to copy my hello.txt in a hello renamed.txt. Here, I need to add this file, hello renamed, and do a commit. Renamed file. Okay. So now, if I want to go through all the files, I want to make sure that he didn't create another blob for me. I just want to have like one blob for the two files that I have. So I want to recreate really fast the, I need the SHA again, but I will do a latest SHA that is this, and it will be the same in this case. So I'm going to do the same here. And I need also like the tree, latest. Okay. And I will just copy this. But it's not SHA, but it's SHA latest. Okay. So now I want to do this one to get this tree latest. So if we go inside here, we have our two files, the hello.txt and the hello renamed. And as you can see here, the blobs are exactly the same. So we have the same blob used for the two files because the content is the same. If I change the content of hello renamed, it will create a new blob. But to save time, to save space, Git just reuses the same blob. So that's how it actually works inside our project. Another thing that I want to talk about is branches, tags, in particular the head, how it's actually, what it means. So branches is like a simple way to point a commit inside our project. So for example, if we have like, we are working on a branch, we have like multiple commits, we can like try to work on a different branch to make sure that we don't mess up our main branch and make like conflicts easier to solve. In this case, we just make a pointer to a specific commit to make our working line a little bit different. And this like creating and like switching from a branch and from a branch to another, it's really a lightweight for Git, and also like really fast. And we'll see also like how it actually works when we actually change a branch. Head is just a specific pointer that it will refers to the last commit that we did. So when we do a commit, the head is actually that particular point when we are working. But head can be also like detached. We can like also like say, oh, we want head to be this specific commit, and in this case, when we are working, we'll start from that particular commit, and we can like go through a new branch, even if it's not like really defined. So let's see how we can like create a new branch. What we want to do in this case is go through another folder inside our .git folder, and inside we've seen the objects, but in this case we want to see the refs. Inside the refs we have the head, that is like in this case it's referred to main, but we can like change it to create a new branch, for example. So here, for example, I want to get into the Git refs, and I want heads, and I think I have main, yes. So here inside, we have like this branch that is our main branch, that is the one that we are working on. But in this file, we have like the reference of head, but we can actually change it. So if I do a cat.git of head, because like we have head, yes. Let's see. Here we have the refs, that is head's main. So that is the reference of head in this case, because we are working inside the main branch, and that's the head for us. But I want, like, for example, to change it and create a new branch. To change it, we just need to change that reference. So if I do echo, and I will take this, that is heads, this case, and I want to create a new branch. And I want to change our .git head. So in that case, as you can see also like from my terminal, we have changed and switched to new branch. And this is how it actually works when you create a branch. It will just go and like edit that specific file that is .git head, and it will just create a new branch, and you can actually work from it. And it's actually really cool to see how we can actually like really change and what's actually happening when we run commands, because we usually just run commands and don't actually know what's actually happening inside, under the hood. But it's like really simple actually. So last thing that I want to talk about is tags, because like tags are really important for me, because it actually points and makes a mark to a specific commit in a specific time of our project. In particular, like when we do releases or like fix something in our project, we can actually add a tag to a specific commit to say like, this is important, we did something here. But we have like two types of tags. I've always like seen lightweight tags being used, so it's just the name of the tag and that's it. But also annotated tags exist, and I think they are really useful because we have like this difference. Here we have like, the first one is a lightweight tag, the classical tag that we usually use. So it's just adding a tag like here, this tag, and we add like the version of our code, and that's it. But actually, we can do the annotated tag. That means that we can add some information to that tag. So here, for example, we have this tag v0.2 that it actually have some other informations. So we can like add a message to it. We have like the same informations about like the commits in that case, so the differences in the files, etc. But we can also like add some metadata to our tag, so we can like add the information about who did this tag, the date, and also like add a specific message, like here. This is a v0.2 and I am an annotated tag. This is like an additional information that sometimes is really useful. In particular, like I actually use it when I'm doing not just like a bug fix or something, but I want like also like to do, if I'm doing like a really specific change in my release. In that case, I will just add an annotated tag to don't like have like different tags, because like sometimes you just added something new that is like different from the other things. So you don't want to change the type of tags that you do, but you want to add like a real information to it. So yeah, that's it, mainly it. Here you can find like all the demo and all the things that I've been playing with today with you. And thank you very much.